algebra students. Today, after our video, we're going to be able to say I can factor perfect square trinomials. And before we do that, I want to recall the types of factoring we already know. We're learning lots of them. First one is GCF, and we should always do GCF first. Okay, try to do it first. It won't always work. So for example, let's see here. I have 24x to the fifth, 16x cubed, and 40x squared. If I don't know the GCF of all of those, I list the factors of the smallest coefficient. And say 2 and 8, and then 4 and 4. And then I check to see if 16 will go into 40 and 24. I know it won't. Will 8 go into 40? Yes. Will it go into 24? It sure will. My GCF is going to be 8 something. All right, now my GCF for my variables is always the smallest exponent. So if there were more than one variable here, I would do the GCF of the x's and the y's and the z's, and in each case take the lowest variable, lowest exponent. So it's going to be x squared in this particular problem. Now remember, my GCF doesn't get tossed away. That 8x squared goes out front. I start a quantity. I do my division. 24 divided by 8, 3. X to the fifth divided by x squared, x cubed. 16 divided by 8, 2. X cubed divided by x squared is x. And then 40 divided by 8 is 5. And then they cancel. And there you go. Okay, just factored by GCF. All right, then we learned how to group. And remember, the only rule for grouping is the terms that I put together have to have a GCF. So I could put 3xy and 5y together. There is a GCF, namely y. I'm going to pull that y out front, get a 3x plus a 5. Going to group these two together, grabbing that sign, sticking a plus between. Looks like the GCF is going to be 6. Pull that 6 out. Going to get a 3x plus a 5. Ooh, that quantity shows up twice. I'm going to get a 3x plus a 5 times the quantity of y plus a 6. And there you go. There's a sample for factoring by grouping. Remember, grouping happens when there are 4 terms. Difference of perfect squares, and that's supposed to be a lowercase. So there are difference of perfect squares. But before I do the difference of perfect squares, remember, I'm going to try to GCF first. And I'm going to get the GCF of 16x and 36x cubed. And I'm going to see here. I don't think 16 goes into 36. 8 doesn't go into 36, but 4 sure does. So I'm going to divide by 4. Divide by 4. There's a variable, so I'll take the least exponent, Ashley Leonard, and I'll divide by x. My GCF comes out. And then I'm going to have a 9x squared minus a 4. Now I look inside here, and I notice that 9x squared is a perfect square, right? Square root is 3x. 4 is a perfect square, 2. So my answer ends up being 4x times the quantity of 3x plus a 2 times the quantity of 3x minus a 2. And there you go. Now, not all GCF problems will have the, not all difference of perfect square problems will have a GCF, but in this case it does. Okay, and then the most recent type we've learned about is trinomials with lead coefficients of 1. For example, this one here. Now notice there's a plus in the back. Remember, that's going to be our Wendy's double stack, meaning this sign is going to show up twice. Okay. I'm going to list the factors of 12. 1, 12, 2, and 6, 3, and 4. And since this is a plus, I need 2 factors of 12 that add to get 7. Well, 3 plus 4. Watch how simple this is to factor. X plus 3 times the quantity of x plus 4. And I am done. Okay. When there's a negative there, I'm going to list the factors of 18, 2 and 9, and 3 and 6. And I believe that's it. Now, since there's a negative here, I need to subtract. I need to subtract 2 of these factors to get negative 7. Well, here's a hint. Since there's a negative in the middle, the larger of the factors I pick will be the negative one. So I know that I need a 2 and a 9 to get 7 using subtraction. Well, it's going to be 2 minus 9. Or you could have said negative 9 plus 2. Either one will get you negative 7. Let me say that again. This is subtraction. So I'm going to subtract my 2 factors. How do I know which one will be negative? Well, if the middle sign is negative, the larger one is negative. If the middle sign is positive, the larger one is positive. So the sign in the middle goes with the larger of the two factors. Now this is just as easy to factor as the one above. I'm getting an x plus a 2 on the quantity of x minus a 9. And there you go. Okay, now we're ready to learn our new type, factoring perfect square trinomials. And this is actually easy. But before we do it, I want to practice with some FOIL problems. Go ahead and pause the video and please FOIL these 4 problems. And if you're wondering, yes, this is a FOIL problem. The answer is not 9x squared plus 16. If you get that, you are incorrect. Okay, make sure you FOIL. When you're ready to see my solutions, I will unpause. Here we go, super speed foiling. If you don't want to see my solutions, pause the video, last chance. 4x squared, let me see, 10 and 18x plus 20. Okay, and this will be x squared. Not sure what I did there. I must have made a mistake, but that's okay. Let's see, sorry, 14x plus 49. And then this will be 36x squared minus 12x plus 1. And this one is going to be 9x squared minus 24x plus 16. Okay, now we're not going to look at this one here. I wrote down the wrong quantity. That's okay. I did FOIL it correctly, but it's not going to help me for what I'm doing. But check this out. Okay, what kind of number is x squared? Well, it's a perfect square, isn't it? What kind of number is 49? Perfect square, right? What's 7 times x? 7x. Double that. Do you get 14x? Look at that. 14x matches in the middle. Let's see if that happens again. Hold on, my airliner is acting funky. There we go. 36x squared is a perfect square. Square root is 6x. 1 is a perfect square. Square root is 1. 6 times 1x is 6x. Doubled, 12x. And that matches there, although we have a negative. The third one, square root of 9x squared, 3x. Square root of 16 is 4. Multiply 3x times 4, and I get 12x. Double it, and I get 24x. Okay, 24x. All right, so that's really not a coincidence. When we have a perfect square trinomial, those things will be true. First term will be a perfect square, last term will be perfect square. If I multiply the perfect squares, get their product, double it, I'll get the middle coefficient. If that happens, then I have a perfect square trinomial. It makes it super simple to factor. So let's see how to do this. Okay, first of all, we've got a trinomial. Is there a GCF hiding in here? No, I don't think so. Perfect square? Yep. 9, a perfect square? Yep. 3 times x, 3x. Doubled, 6x. It matches, doesn't it? Watch how simple this factors. Square root plus square root times square root plus square root. How did I know to make them positive? See this plus in the back? That's a Wendy's double stack. That sign shows up twice. Goes there, and it goes there. Okay, let's try that again. Got a trinomial here. Are there any GCFs hiding other than 1? I don't see one. Square root, perfect square? Yep, square root is x. Perfect square? Yep, square root is 5. Multiply 5 times x, 5x. Double it, I get 10x. It matches, doesn't it? Here's how it factors. X minus 5 times the quantity of x minus 5. Now I'll bet you're wondering why there's a minus there. Well, when there's a plus in the back, it's the Wendy's double stack. And that negative shows up in both quantities. Not like the difference of perfect squares. We get one of each. In the perfect square trinomial, we get the same sign both times. Okay. GCF hiding in this trinomial? I don't see one other than 1. This is a perfect square. 2x. This is a perfect square. 10. Oh, 10. Silly me. 5. 2x times 5. 10x. Doubled. 20x. Does it match? No. This is not a perfect square trinomial. I don't know how to factor it right now. Okay, so I can't factor this one. Right now you would tell me it's prime. It may not actually be prime. There may be another method of factoring that we're going to learn, say, early next week. But for right now, this one is prime. Okay, let's take a look at this one here. A trinomial. Is this a perfect square? You bet. 49x squared. Take square root, 7x. Is this a perfect square? Yep. Square root is 4. 4 times 7x, 28x. Doubled, 56x. Okay, 56x. Plus in the back, Wendy's double stack. Here we go. 7x plus 4 times 7x plus 4, both in quantities. If you're lazy like me, you could write 7x plus 4 quantity squared. Either answer is acceptable. All right, 2 more to do here. Got a trinomial. Perfect square. Well, first of all, GCF. I don't see a GCF. 121x squared is a perfect square. 11x. 1 is a perfect square. Multiply 1 times 11, and I get 11x doubled 22x. Ooh, it doesn't match. Tell you what, I had wanted it to match, and I had made a small mistake there. So I'm going to go ahead and change that to a 22x. Hope that doesn't mess you up too bad. I want it to factor as a perfect square trinomial. So I'm going to actually change that, my mistake. Now here's how we factor. Plus in the back, Wendy's double stack. 11x plus 1 times 11x plus 1. I notice that plus shows up in both quantities. All right, 144x squared minus 312x plus 169. I don't know if there's a GCF there. But these numbers are not so friendly. I'm probably not going to go looking for it. I could always pull it out later. I see a perfect square, 12x. I see a perfect square, 13. 12 times 13 is 156, and it would be an x. Double that is going to be 312x. Plus in the back, Wendy's double stack, 12x minus 13 times 12x minus 13, both in quantities, and I'm done. Okay, so we have a trinomial. We pull the GCF out if there is one. If the first and third terms are both perfect squares, we find their square roots, we multiply them together, and then double that answer. If that matches the middle coefficient, we get the 2 square roots in each quantity. Okay? And then the sign in the middle is the sign that we use for both quantities. All right, that's it for today. Mr. Lawrence signing off. Have a good night, everybody.